welcome to class 10th. Okay, I really appreciate your efforts, whatever you have done till your 9th grade. Okay, now we're starting 10 today, and we're doing the first chapter of 10th standard. I would be saying that best of luck. Okay, I hope you will get very good mark in 10th grade, and definitely you will get right because I'm going to teach you. Okay, and when I teach, I definitely make sure about this thing that my students will get as much as they can, right? I'm going to discuss all the important things, what could be the thing that could come in the exams, and whatever stuff is there, right? Okay, fine guys. So I start into this class without even delay of a single second. Okay, perfect. So guys, basically, in today's session, what we are going to learn definitely the first chapter, okay, of mathematics, okay, of I would say your grade, 10th grade, okay, and in that chapter, we are going to learn, that the name of the chapter is real number. First of all, okay, I should tell you the name because you might don't know the name even. The name is real number. In the chapter, we are going to learn, about Euclid's theorem is there, and how to find that CF and LCM is there. You know about it already, right? I know you know about it, but I'm going to teach you this thing by a different method, I would say. Okay, fine. Yeah, and there are many more things that we are going to discuss in the chapter. Let's start then without wasting a single second. Okay, guys, so I'm sharing my screen. Just a moment. Just a moment. I hope my screen is visible to everyone, right? Okay, let's start the slideshow. So guys, today's topic is real number. And if I talk about the weightage of the chapter in the board exam, it's 6 marks, okay? And I would not say now it's a 6 mark, it's more than that as well, right? Okay, so the weightage of the chapter is really good. And in terms of difficulty level, chapter is easy, man. Chapter is easy, okay? You can learn very easily and you can score such good marks in this chapter, okay? Let's start then. Fine. So guys, in today's session, as it is the first class of ours, what we are going to learn is we are going to learn about the Euclid's division lemma and the algorithm versus lemma, and we are going to learn the Euclid's algorithm as well, okay, to find the HCF and LCM. But before that, let's have a quick review that what we have learned in the earlier classes. Okay, we have learned about the real number, guys, first of all, right? Okay, so over here, if you see in the figure, it has been shown to you that how the real number and the integers, the whole numbers, and the rational numbers, they have the connection, right? Okay, so all of them falls under real numbers, right? In the under the branch of real number, there is two kind of things we can say. One is called rational and one is called irrational. Both of them are real. Okay, now rational are the numbers which can be written in the form of p upon q that you have learned, right, where q cannot be 0. And irrational numbers are the number which we cannot write in the form of p upon q, right? For an example, is square root of any odd number, root 2, root 3, root 5, not 1 definitely. Okay, pi is also an irrational number, right? What you are wondering about? I know. You will be saying, sir, pi is 22 by 7, right? We have just said that an irrational number is written as in the form of p by q, right? In the form of p by q, you write it. But we are writing pi as 22 by 7, and that's in the form of p upon q. And then why you are saying it's not rational? It is rational, sir. We have wrote in terms of p by q. Array, no, my kids, it is not true. The reason behind that is that pi is not 22 by 7. Pi is almost 22 by 7. The value of pi is almost 22 by 7. And that's why we cannot say that it is a rational number. 22 by 7 is something that we just use to solve the problems. Got it? Okay, yeah. Now if I talk about the rational number, in rational number you have the integers are like -1, -2, -3, -4, -5, 1, 2, 3, 4, 5. They are integers, right? Okay, and then you have the whole numbers. Okay, so whole numbers is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are the whole numbers. And then you have the natural number that occur naturally, 1, 2, 3, 4, 5. Do you know why we call them natural number? Okay, can you show me one bottle of water? Yep, it is there. One bottle of water. Yeah, it is there, right? Can you show me one bottle of water and one pen? Or I would say, can you show me two pens? Yes, I can show you two pens, right? Okay. Can you show me 0 pens? Show it to me. Oh, come on. I cannot show it actually. There is no pen. When there is no pen, I would say it's zero pen, right? Okay, but I cannot show it to you now. So that's why it's not natural. Natural is something that which is occurs in the nature itself. Okay, one pen is in the nature, one tree is in the nature, one person is in the nature, but 0% isn't in the nature, right? We cannot show it to you. Okay, to show one, I have the finger, right? But to show zero, which finger I have? I don't have anything, right? To depict it. Okay, that's why we have taken zero as a not taken as a sorry, we have taken zero not as a natural number. It comes under the category of whole number, but not natural numbers. Got that point of mine? Okay, that was a quick review that what we have learned in the ninth grade. Now, guys, we are going to talk about the Euclid's division lemma. Okay, now I'll tell you one thing. So Euclid क्या था कि Euclid was a very clever person. Okay, he has given a name Euclid's lemma to a simple thing that all of us already knows. Guys, you know that um, dividend equals to divisor into quotient plus remainder. Okay, I hope you know that, right? So I'll tell you, let's say if you are dividing 25 by 6, you get the divisor as 4. You get, sorry, the quotient as 4. You get the dividend as 25. You have the divisor into quotient plus the remainder. That's how you write it, right? Okay, so what I am using is that I am using dividend equals to divisor, divisor into into quotient plus remainder, right? Okay, so actually Euclid has said the same thing. He said the same thing. What he said is that any number a can be written as b into q plus r. Any number a and b, you can understand like that. A number a and b can be written in the form of a into a equals to b into q plus r, where r would be always more than equals to 0 and less than b. So what is the logic behind that? Look, guys, we know that dividend equals to divisor into quotient plus remainder, and we know one more thing, that remainder is gonna be always lesser than the divisor, right? Definitely, if you are dividing a number by 5, the remainder cannot be 5, right? It will be less than 5. It can be 0, 1, 2, 3, 4, but it cannot be 5. Okay, and that's what Euclid said. He said that the remainder cannot be more than the quotient. It will always more than 0, but it will be always lying in between 0 and the quotient, right? That's true. Okay, and he said that this is applicable in case of two positive numbers a and b. Yeah, that's true, right? Okay, so what was the Euclid's lemma actually? If I understand it like that, Euclid's lemma is that any number, okay, any number a, or I would say in a more appropriate manner, so I would say that if we have two positive integers a and b, okay, then there would be a whole number q and r that is going to satisfy the equation a equals to bq plus r, right, guys? And yeah, that is true. I mean, like, when you learn this, when you read this, basically a lemma, you think that, oh my god, what is that? What he's saying, that if we have two positive numbers a and b, then there would be a whole numbers q and r that satisfy the equation. We wonder about that, but actually it is not something we need to wonder, because it's already we knew that dividend equals to divisor into quotient plus remainder. We can write the dividend as product of two things plus the remainder, and that's what he said. He said that a number a equals to b into q plus r. What is a? A is dividend. What is b? B is divisor. What is q? Q is quotient. And what is r? R is remainder. And we know that the remainder is going to lie in between 0 and the divisor, right? And that's what he said. Okay, so I hope it is quite clear to everyone what is the Euclid's lemma was, right? Got it? Okay, there's a doubt. No doubt, right? Okay. I think just a second, guys. I need to insert a slide over here, just to make sure that you guys first solve some basic problems, okay, based on the lemma, and then after that, definitely we are going to discuss some high level problems as well. But I think that we'll discuss later on. First of all, let's try to solve the basic problem, because what is that important right now for us to understand the basic problems, right? Okay. So the problem for you guys is that find a b q r. I mean, like, whichever is not given, you need to find that. Okay, so if a is 37, b is 6, in that case you need to find q and r. Okay, guys, if A is, let's say, a not given, B is, let's say, 24. Okay, Q is, let's say, 9, and R is, let's say, 3. So you need to find the value of A, right? In that case, question number 1 and question number 2. Okay, let's do these two questions. Take your time and solve them. If you have a doubt, please ask me. Okay, I'm here to solve your doubts only. Okay, yeah, think about it. Take a minute. As I said, Euclid's division lemma is nothing but you are dividing a number. That's it. You don't need to worry much to solve the problem. Give it a try, please. Acha, just a second. I understand that thing was troubling you, right? No problem, no problem. Just a second. Just a second. स्लाइड शो वाला खोलना था ना, दूसरा विंडो गलती से ओपन हो गया था. अभी ठीक है, right? Fine now. Yeah. Okay, let me discuss now. देखो, so as I said कि you just need to divide the number. Okay, so अभी मैं ऐसे बच्चों की तरह दिखाता हूँ जैसा आपने बचपन में किया था. 6 are 36. 1 is remaining. Dividend equals to divisor into quotient plus remainder, right? So A is given to you. A is 37. B is 6. Okay, so what is Q? The quotient is also 6. And what is the remainder? It is 1. Got it? I mean, we can also say one more thing, क्या? कि that the remainder lies in between 1 and the quotient, the divisor, and that is 6. So yeah, it is. अभी आपको ना exam बस ये लिखना होगा. That's it. Yeah, it is satisfying Euclid's division lemma, right? Okay. So look at this. We know that A equals to what? BQ plus, and there's no formula. It is like, again, as I said, divisor into quotient plus remainder. Okay. So it would be, I think, 219, right? Yeah, 219. Got it? Is any doubt about this simple question, right? So this was the first kind of question that comes under the genre of Euclid. Okay. Now let's discuss second kind of questions. Fine, guys? Okay. Yeah. देखो अगला क्वेश्चन ये है कि use Euclid's lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1. So what is happening over here, that we need to show that there is any positive number. If you do the square of that number, it would be either in the form of 3m or 3m plus 1. I'm like, what is the meaning of the question? First understand that. देखो, अगर मान लो कि कोई भी नंबर का स्क्वायर किया आपने, 25 एक नंबर का स्क्वायर होता है, एक 7 का स्क्वायर 49 ले लिया, एक कुछ भी लो आप 12 का स्क्वायर 144 ले लिया, राइट? अब देखो आप, कैन आई राइट 25 as 3 into 8 plus 1? Can I write 48 as 3 into 16 plus 1? And can I write 144 as 3 into 42, right? No, sorry, why 42? It would be 48, right? So what you will see over here is that any square of any number, these things can be written as 3 into something plus 1 or 3 into something. That's what he's saying. That it is either 3 into something, that is any integer, 3 into something, that something is any integer, or either it would be in the form of 3m plus 1. Okay, so we need to prove this fact. This is a fact. This is true. You need to prove it, but right? Okay, so some people actually argue यहाँ पे कि सर देखो मैंने इसका स्क्वायर किया, ये भी 3 into something plus 1 की फॉर्म है. समझ लो guys, 3 into something plus 1. What I'm saying that we need to prove that the square would be in the form of 3m plus 1. 3 into a number plus 1 की फॉर्म में होगा, तो ये उसी फॉर्म में तो है. 3 into 8 plus 1, 3 into 16 plus 1, and it is just 3 into 48, right? So but this is not a proof. Why? Because it is just you have taken 2-3 numbers, you did their square and it is coming in the form, right? But they're infinite numbers now. So how you are so sure कि ऐसा होगा ही होगा हमेशा? Not sure ना. So we're gonna prove that now. Okay, just pay attention on how to solve this kind of questions, right? देखो. So what you do is that first of all ना इस question में क्या करोगे आप? You will let any number. Okay. अब एक बात बताइए आप, if there is any number in the world, that number is divided by 3. So what's gonna be the remainder? 0, 1 or 2. So can I say that any number in the world can be represented as, let the number is, let the number is either it's gonna be 3 times of some number, multiple of 3, or when it is divided by 3, remainder is 1, 3k plus 1 की फॉर्म में नंबर है. Or let's say if it is divided by 3, remainder is 2. अब remainder cannot be 3, right? Because if you are dividing a number by 3, remainder can be 0, 1 or 2. So जो नंबर है वो आपका है तो 3k होगा या 3k plus 1 होगा या 3k plus 2 होगा, any number in the world. Okay, now if you are doing the square of that number, we need to prove that it will be either 3m or 3m plus 1. ठीक है, मतलब ये या तो 3 into a number होगा या 3 into a number plus 1 होगा. ठीक है, so let's take first of all 3k. मैंने बोला कि एक काम करते हैं, फर्स्ट नंबर इज 3k. 3k का स्क्वायर किया आपने, वो है आपके पास 9 into k स्क्वायर. ओके, इसको लिख सकते हो आप 3 into 3 times of k square. आप देखो 3 times of k square is what? It's just a number ना, तो can I say it is in the form of 3m? Yeah, 3 into a number, 3m की फॉर्म में हो गया वो. अब लेट्स से अगर आप करोगे 3k plus 1 का होल स्क्वायर, वी आल्सो नीड टू शो दैट कि वो भी ऐसे ही फॉर्म में आएगा. लेट्स सी, it will become 9k square plus 1 plus 6k, right guys? Pay attention on this thing. I can write 9k square plus 6k plus 1. If I take 3 common, it would become what? 3k square plus 2 k, okay, plus 1. अब ये again this is a number ना. Okay, so again what again I can say it is in the form of 3 into a number m plus 1, right? A number can be anything. If I'll do the same thing with 3k plus 2, let's see what I'm getting. I'm getting 9k square plus 12k plus 4. Okay, I can write it as 9k square plus 12k plus 3 plus 1. If I take 3 common, it would become 3k square plus 4k plus 1, right? Plus 1. तो वापस से कोई एक नंबर हो चुका है. This is any number. I can write that as m again. So it would be 3m plus 1. So 3m plus 1 की फॉर्म में आ रहा है या तो, या फिर it is coming in 3m's form, right? सो अल्टीमेटली आपको इसमें ये प्रूव करना था कि द नंबर शुड कम इन दैट फॉर्मेट, एंड दैट फॉर्मेट इज 3m और 3m plus 1. वी प्रूव दैट, राइट? अब इस पैसे में बोला सर यहाँ पे तो आपने 3k स्क्वायर प्लस 2k को m लिखा, यहाँ पे 3k स्क्वायर प्लस 4k प्लस 1 को m लिखा. व्हाट, व्हाई दिस नाइंसाफी? ऐसा काहे कर रहे हैं? तो बहुत सिंपल सी बात है, बिकॉज आई एम जस्ट सेइंग दैट इट शुड बी इन द फॉर्म ऑफ 3 into a number plus 1, and that number is not given to me. It can be anything, right? It's just that 3 into an integer plus 1. So 3 into 3k square plus 4k plus 1 भी एक integer है, 3k square plus 2k is also an integer. They can be different but they are integers, right? Got my point now? फाइन है सबके लिए? अच्छे से ऐसे ही करना है क्वेश्चन हमें जस्ट आपका, ठीक है? बड़े आगे ये सा सॉल्यूशन दिया हुआ है यहाँ पे, जैसे हमने किया सेम उस तरह से दिया हुआ है, तो इसमें कुछ भी नहीं है, हाँ समझ में आएगा हमें, तो लेट्स मूव फॉरवर्ड. हाँ, सो अभी यहाँ पे इंपॉर्टेंट कॉन्सेप्ट जो मैंने आपको बोला भी था कि हम इस चैप्टर में आज बात ही इस बारे में कर रहे हैं कि यूक्लिड्स डिवीजन लेमा क्या है, यूक्लिड्स डिवीजन एल्गोरिथम क्या है. तो हमने लेमा अभी पढ़ा, दैट a इक्वल्स टू बी क्यू प्लस आर होता है. अब ना जो है डिफरेंस समझना है आज हमें पहले इनके बारे में कि व्हाट इज डिफरेंस बिटवीन अ लेमा एंड एन एल्गोरिथम. देखो, एक स्टेटमेंट जो कि एक प्रूवन फैक्ट है, ओके, that statement will be used to prove the other things is called a lemma. जैसे मैंने आपको बोला, जैसे कि आपने ट्राइंगल में क्लास 9th के अंदर एसएएस पढ़ा था, एसएएस कॉन्ग्रुएंसी आपने पढ़ी थी, राइट? You learn SAS congruency in 9th standard, and then by using the SAS congruency you have derived the other congruencies, right? But SAS was a lemma, that was a proven fact. So dividend equals to divisor into quotient plus remainder is a proven fact. Okay, we cannot prove it, we can we cannot derive it, I would say. We can just show it, yeah, it is true, it is satisfying the all the numbers, but we cannot derive it in that form, right? Okay, that is called a lemma. Got that? अब बात करते हैं what is the meaning of algorithm. देखो, algorithm is something that is you can say कि एक सीरीज होती है एल्गोरिथम, ठीक है? देखो यहाँ पे लिखा भी है, सीरीज ऑफ वेल डिफाइंड स्टेप्स टू सॉल्व अ प्रॉब्लम इज कॉल्ड एल्गोरिथम. आपने पढ़ा सुना होगा काफी बार ना, एल्गोरिथम क्या लगा, यूट्यूब की एल्गोरिथम होती है, यूट्यूब की क्या एल्गोरिथम सेट की जाए, ऐसा आपने सुना होगा किसी को बोलते हैं. तो एल्गोरिथम का मतलब होता है कि एक सीरीज होती है चीजों की, ठीक है? और वो सीरीज जो होती है वो काम आती है किसी प्रॉब्लम को सॉल्व करने के लिए. ओके, अभी we are going to learn about Euclid's division algorithm only, and we are going to see that how we solve the problems based on Euclid's division algorithm. Okay, let's move forward. अभी सीखते हैं इसको, डोंट वरी अबाउट दैट. देखो, जैसे यहाँ पे क्वेश्चन है हमारे पास कि फाइंड द एचसीएफ ऑफ 81 and 675 यूजिंग द यूक्लिडियन डिवीजन एल्गोरिथम. सो हाउ इट वर्क्स, लेट मी शो इट टू. देखो, सबसे पहले आपने लिखा 675 इक्वल्स टू 81 into समथिंग. ओके, तो डिवाइड करना पड़ेगा, करो डिवाइड. सो आई थिंक 8 टाइम्स करोगे, आई थिंक सो 8 8 और 64 648 आ गया. 648 आ गया तो आपके पास बच गया है 7 और 27, राइट? चेक करते रहना। 27 बच गया। अब देखो आपने क्या किया। You wrote A equals to BQ plus R. It's satisfying Euclid's division lemma. Okay, where you can see that 27 lies in between 0 and 81, right? Okay. Now you use the Euclid's lemma again, but now you will earlier you will have used like it was A equals to BQ plus R. Up now you use the same lemma in B and R. Okay, so you'll write 81 equals to 27 into 3 plus 0. So definitely there gonna be one step at which you are like ऐसे solve करते रहोगे बार बार आगे नीचे आओगे नीचे आओगे नीचे आओगे. So at the end there would be one step where you will be getting the remainder as 0. जहां पर रिमाइंडर 0 मिल जाएगा जैसे यहीं पे रिमाइंडर 0 मिल गया स्टेप के अंदर. The point at which you get the remainder as 0, at that point whatever divisor you had, that divisor is called the HCF, right? So over here the HCF of these two numbers would be what? 27. Okay, तो नॉर्मल मेथड लगाओगे तब भी आंसर यही आएगा, राइट? गॉट इट? ये थे आपके यूक्लिड जी. हेलो यूक्लिड जी, हाउ आर यू? ठीक है, तो इन्होंने ये डिलेमा दिया था, ठीक है ना? सो यहाँ पे इन्होंने बोला है कि 27 आ चुका है आंसर. मैं आपको कुछ और दिखाता हूँ सॉल्व करके. जैसे यहाँ पे देखो एक क्वेश्चन है कि क्वेश्चन नंबर 2, यूज यूक्लिड्स डिवीजन एल्गोरिथम टू फाइंड द एचसीएफ. सो अब मैं फिल करते हैं क्वेश्चन को, कैसे करते हैं. पहले लिखा आपने 225 इक्वल टू बड़ा नंबर, डेफिनेटली बड़ा नंबर टू बी लेफ्ट हैंड साइड, राइट? 135 टाइम्स 1 प्लस क्या रिमाइंडर आएगा देखिए आप. द रिमाइंडर वुड बी 65 और 25, राइट? दैट कितना हो गया हमारे पास? 90 हो गया, राइट? है ना? अब वापस सेम चीज लगाएंगे इन दोनों के बीच में. कैसे लगाएंगे? दैट 135 इक्वल्स टू 90 इंटू 1 प्लस 45. सो फार रिमाइंडर इज नॉट जीरो ना. अभी देखना रिमाइंडर कब जीरो आएगा. फिर 90 इक्वल्स टू 45 इंटू 2 प्लस yeah, remainder is zero. That means the HCF would be what? The last divisor, and the last divisor is what? 45. So 45 is their HCF, right? हाँ, one more, definitely we gonna write that, don't worry about that. ये लिखेंगे हम लोग ना, just to make sure कि हमें सब आता है. हम बहुत समझदार हैं, हमने ये भी लिखा. Because obviously the remainder should lies in between the 0 and the quotient, right? And the same manner the remainder should lies in between the 0 and the quotient, right? So we write that to show the examiner that we are quite intelligent, right? That he will have no clue to deduct our marks. Okay guys, okay, got that now? Is there any doubt? So we are on question number 2. Clear है आपको? अच्छे से clear है? ठीक है. Question number 1 is gonna be your homework. Question number 3 is gonna be your homework, right? Okay, so I hope everyone is clear about the class today. Is there no doubt? ठीक है, ठीक है. 45 आंसर है, मैंने बोला ही था आपको, ठीक है ना? ओके देन गाइस, बाय बाय, टेक केयर, एंड प्लीज नाउ you can solve the first few questions of your module and your book as well, NCERT book. And yeah, definitely you whatever doubts you're gonna have, you will put the doubts on PDF, right? And you can mention always me. Deepak sir is always there to help you, right? Okay, and soon I'll be also telling you that which questions are really, really important from this chapter that might come in your board exams. Okay, okay guys, bye bye everyone, take care, have a nice day ahead. I hope you enjoyed the class. Bye bye.